Hello everyone, welcome back. This is the next video in the Python fundamental series, and we're going to talk about lists. Lists are one of the probably most commonly used container types in Python. Um, and I want to start doing this at the top of my scripts now. So I'm gonna use the triple quotes for this aspect. Because I'm gonna create a little section under triple quotes. You can add like text and stuff that doesn't have to be ran through the compiler. And I'm gonna start just at the top of the scripts, just put kind of in general what the topic is about. So for instance, just in the future, when you go back to your code and you want to remember what the list was, or I didn't do this with the first few videos, but going forward I would try to give a little background on that topic a little bit before we actually go into it. So for instance, a list is an ordered pair of sequence of items. So that means that when you put things in a list, that its position is counted, and it's counted in a manner in which it went into the list. So the first item going to the list is in the first position, or the 0th index, the second item, the third item, the fourth item, and so forth. So that's what it means by it's an ordered sequence items, an ordered sequence of items. A list can have different data types. So we've talked about numeric data types. We've talked about complex data types. We had a video about strings, which is a data type. We talked about booleans. A list can hold all of these different things. Just look at it as a list. It's like a purse with many pockets, and the pockets are ordered, and each item can go into a pocket, but it always go in the order in which it was received, unless you tell it to replace or move that item, or move the placement of that item into a different pocket. That's kind of how the premise of the list. Because the list data type is so versatile, it's probably one of the most common data types used in Python, and it's definitely the most common data type that's used to convert to other data types. We're not going to talk about NumPy arrays and stuff, but a lot of times there's conversions to get lists into other types of data types to make processing of data a little faster. But in the end, at its root case, list and strings. List, if strings is number one, list might be the number one data type I think that's used a lot in Python for different types of research or different types of work. Alright, so we can have different data types, and it's ordered, and it allows changing and so forth. So based on that, that's the end of the kind of the classroom talk. Let's go ahead and get it. Let's get it. Alright, so we're going to get started. First, we're going to talk about creating an empty list. So I got a new project open again, just in my main. Alright, so when you want to create an empty list, let's type in empty list. An empty list is created by just using brackets. So that's I know I'm gonna create three variables for this assignment, trying to be a little bit more uniform. We're gonna have a list of names, we're gonna have a list of ages, and we're gonna have a list of weights. That's kind of the data sets we're going to play with for this tutorial. So if I wanted to create an empty list, I would just say names, that's the name of it, and then equal, and then open and close brackets. If I shift enter this, you'll see that over here it'll tell you, if I double click, there's nothing in it, but it would tell you that this is a list, type list, size 0, and open bracket. So this is how you instantiate a list. Very common, especially if you want to do some different types of work. But I just want you to make sure that when you see double quotes in code, this double equals double quote, that means that they've created an empty list. Okay, all right, so now we're going to put some stuff in our list. So I want a list of names. So let's go, names is equal to open brackets, because names are strings, we need quotes, or double quotes or single quotes. So I'm going to use between doubles and single quotes. I'm going to have Michael. I'm going to create the name Sally, and the name Jim and Carl. Jim and Carl. A-R-L. Alright, shift enter. And there we go. Now the list has changed. If you double click now, you'll see that there's 4 items in it. Their size. Oh, I misspelled Michael. I'm gonna fix that. I'm glad I misspelled it so I can show you how to fix it. Michael, Sally, Jim, and Carl. 0 to 3 indexing, but there are 4 items in the list. Kind of what we talked about last time. let's go ahead and create the other list, and I'll go back and fix. I want you to create a list called ages for those. So I'm gonna say, you know, as of today I'm 40. Got 23, 12, and 67. It's the ages for the 4 people. So how I'm writing the list is that, you know, this corresponds with the same position. So that's the ages for the 4 people, and then we have the weights, and this is their weights. And then I think I put I weigh 238, and then I'm gonna make up weights for everybody else. 123. I'm gonna say 123.5 just to show a different data type in there. 250 and 80 pounds. So just making up numbers. All right. So now, and you notice, I want you to notice what I did on that one. In this list, it has both integers and a float. So that's what we mean up here when we say you can have integer, float, strings. All these things can be in the same container types because it's just holding data. All right. So to access elements in the list, it's the same thing we've done in the other videos. Is that it's 0 index. So if I want to return Michael on the screen, I can just say, let me see, names, and Michael is in the 0th position because it's in the 1st position. And I do shift enter, you'll see the output is that Michael that was here. So names, 0 position is Michael. This is what matches. Now list, what's beautiful about list specifically is that list allows for you to change the data once it's been created. So there are data types that you can't change once they're created, and tuples are one of those data types. Once a tuple is created, we talked about this in earlier videos, the one with the parentheses, you can't just change it. You have to like it's more of another secure feature of a tuple. It makes sure that stuff don't easily get copyrighted. Copyrighted. Well, I meant, well, not copyrighted. Copy over by accident. But for list, I can do that. So I know name is in that 0th position, right? I can go here to correct my name and say names. Give me that position that represents Michael, but I want to say equal to Michael. M-I-C-H-A-E-L, the correct spelling. So when I do shift enter, you'll notice in the names list, Michael was changed. Now Michael is M-I-C-H-A-E-L, which is how it should have been spelled, and then Sally, Jim, and Carl. So you can change and look up or return different values of a list just by going through each of the different elements. To be more blunt with the mixed data type, I could have created the list like this. I call it combined list, just to show you can have one data type that had it all. So what if I said combined list would be open bracket. I could have said Michael is 40. You know, if I put the data together, and then 238. So what I'm doing, I'm just creating a list that put all the like information together. Sally is 23 and 123.5. Jim, it's a string. Jim is 12 at 250. Man, Jim is a big 12-year-old. And then Carl is 67 and 80 years old. Okay, so if I do shift enter here, as you see, it's not an issue. So these were 4 each. This one is 12, and it has all the data that we created. And given what position of the item, it will determine the type. So for instance, like in the combined list, if I want the type of the combined list, I'm gonna get a list because that's its type. Its type is an object. But the type of the combined list at position 0 is a string. So at that position, this object inside this list is a string, which is right. Michael is a string. So therefore its type at this position is a string, which means that when I use this type of syntax, I'm referencing a string. So any of the string commands that we've talked about will work here. If I wanted to use the dot strip, dot replace, what we talked about in earlier videos, all that exists here, if I hit dot and look up strip, you'll see the strip show up because it knows that this is a string, that this with the 0 index is actually referencing a string. Now if I go back here and change this to a 1 to do shift enter, it's an integer. So you see that? Now the 40 is an integer, so therefore it's going to return an integer. If I do dot string, I don't think it's going to, yep, I try to do strip. You notice that there is no strip because at the 1 position you're not dealing with a string anymore, you're dealing with the integer. So you got to remember that when you access by index of a list, when you get to that position, you are actually a new, if it's not, unless it's another list in that position, but whatever data type in that position is what you have access to. And you remember, everything in Python is class oriented, so you have access to that class, which means you have access to its attributes and its functions, and anything that goes with it, and any other type of durations that goes with it. All right, so so that's kind of how the base principle of lists are. Again, you want to know the length of a list. You can see it up here in the GUI. It says length 12, lets you know how many items in a list. But if you didn't have the GUI, the length command still works. So if I do a length of the combined list, I'm gonna get 12 back because that represents the number of items that sit in the list. But you remember that it's 0 indexed, so you just have to make sure you remember what we covered on that one. Again, the same systems work for slicing, so we'll do a couple slicing examples. So if I say index slicing is what it's called. So we already said how to get the first item in the list. If you want the last item in the list, you can do -1 like the other ones. So if I do -1, this where it returns the last item, which is 80 of this list. If I open up comeback list, you see it's an 80. Or I can get the length of the list, which is 12 minus 1 will give me the last one. Remember here it's 11, so the length of the list is what we got here. So if I copy this piece of line of code and put it in here, instead of with a -1, I put that there, and then subtract by 1, that also gives me 80 because this is 12 minus 1, which is 11. So this is 80 as well. So these two give you the same thing. And again, the same thing. If I want the first 2 items of the list, you have to like the first one is inclusive. You remember, so 0 that would include Michael. So if I want Michael, all of Michael's data only, you have the 0 position, the 1 position, the 2 position. That's what I want. But I gotta go to the 3rd position because what you put here is not, in the 3 does not include salary. That's exclusive. So it's going to exclude whatever is in the position of this index, and what's in the position of this index 3, 0, 1, 2, 3 is salary. Therefore, when I hit shift enter, I get Michael 40 and 238 back because salary is excluded because it's in the exclusion index. Again, so, or the opposite, say you wanted everything except Michael's data. So now it works differently in regards to when you do it that way, because the first, in that one, you'll put something in the first index, which is the salary, but you won't put nothing in the back index. So for instance, if I say combine and I want Sally, you know, Sally's in the 3, but I just don't want nothing else. What I would do, I would just do 3 double what is this called? Quotes, not quotes. A colon. Man, I forgot my symbols for a split second there. You know, 3 colon, and what this does, it will start at the 3rd index, which is Sally in this case, and then give you everything after Sally. So if I do shift enter, you'll get the rest of the list. That's how you can go that way. If I'm not mistaken, I haven't done this in a while. You can get specific items out of a list by passing in. I think you can do that by passing in a list. So like if I do combine list, and if I want it, I have to create another list. So a list within a list. No, you know what? I'm gonna do this differently because that's a little confusing. So if you want specific items out of this list and you know their index positions, you can create what I call an item index list. So item index, list, and say I want Michael, which is in position 1, 0. I just want the names. I wanted Sally. Sally's in 3. And then Jim is in, let's see, 0, 1, 2, 3, 4, 5, 6. Jim is in 6, 7, 8, 9. And Carl is in 9. 6 and 9, right? And so we got this, what I call this index list. Oh, my bad. I forgot the equal sign. So now we got this index list. So now I'm going to pass this list into this list. So I do shift N. Oh, okay. So you can't do that. So it says list indices must be integers or slices. And because it has to be slices, you can't, this is not a slice. You can't add another list. So this is something you can do in other data types. You can't do this with the list, so discard. This is not possible. All right, so if you want to go through the list, you have to use the list types that I mentioned earlier. All right, what else I think I need to go over in regards to slicing? I think that's that. All right, so another thing we didn't talk about it. You can have lists within list. So right now we have let's see, 1, 2, 3, 4, 5 lists, right? I can have a list that represents all these items in a list. So a list of lists, and it's very common. So your access, the way you access is a little different, because the first access to get you to the list, then you have to do a second access to get to the item. So let's create it. I'm gonna create a list of these items here. I'm gonna call that list all, just using it as an example. So we say all is equal to, I'm opening up a list, and I want a list of ages, combined list, item index. Since I've created it, I might as well use it. Item index list, names, and weight, EIGHTS. Okay, why is you complaining? Oh, it's saying I must have misspelled this. Item index list. Oh, it is defined. I'm gonna do shift enter and see what happens. Yeah, this is an error that's not true. I've noticed that item, oh, I know what happened, because I deleted it. It is acting up because I deleted it off the screen. It doesn't realize what's in memory. It's just looking at what's written in text. So just to let you know, I'm gonna put it back so it won't have this error. But the error exists is because it can't find item index list, because I deleted it from the script. If I put item index list back up here, equal to, I'm not gonna hit, I'm just gonna say equal to 0. It'll make the error go, but I don't want this to go away, and I definitely don't want it to be 0. All right, so we have this list now. If you notice, we go to the all list, you'll see that in position 1 you have a list. In position, I mean not 0, in position 0 you have a list. You have in position 1 you have a list, which is that's the combined list of everything. Position 2 you have a list. Position 3 you have a list. Position 4 you have a list. So say for the first list, I wanted to get the value for 12. So you remember 12 in this list, 12 is in the 0, 1, 2, the second position of this list. Okay, so when you're referencing the all list, since it's a list of lists, first you got to get access to the actual list. So if I say all open bracket 0 and do shift enter, what that does, this outputs the list in this position, which is this list. So now I want the 12 to return back. So now I got to give it the index of that position, which is 2. And how you do that here, outside of this one, you'll open up another bracket, and then you'll put the number 2. And what this does, this will give you, this gives you access to a list. So this is the first list. This is the second position in the first list, is 12. So again, the 0, open this up, 0 got you to this line in code, to this line in memory, or to this location in memory, and the second one gave you the position of this value at this memory location. So that's the 12. Again, if I wanted to get, I don't know, Jim out of the third list, that'll be 0, 1, 2. So to get Jim, I will change, you know, let's enter all. It's the third list, which is the second index, and then Jim itself, it's in 0, 1, 2, 3, 4, 5, 6. It's in the 6th place. So 2, 6, shift enter. I'm out of range, so I must 0. Let me pull this back up. Oh, I'm wrong. I like this mistake. I thought it was in the third position. I had made a mistake, and I was looking at the position outside my environment explorer. When I pulled this back up, the combined list is actually in the second position, which is the 0th position. The third position is 0, 3, 6, 9, which is that item index list. So I need to change it to 1, and then Jim is still 9. So always look at this to see where you are. So this should have been 1, not 2. On my computer, it's all about if you're following along closely. Be 1, 6, and now you get Jim back. So that's how you can go through and access different things from a list. Okay, so another thing you need to know, you can always a list allows you to do different type of manipulations. I call them I'm trying to figure out the best way to do it, but let's just call this section list manipulation. So what I'm gonna do here is just go through and talk about different ways you can manipulate a list. List manipulations. Hopefully that's correct. So one of the things you can do to a list, you can always add to it. So like the name list, I'm gonna add another name, and you'd use that by using the append function. So I can say names dot append, and then I can say what I want it to be. I'm gonna say Sarah. We're gonna add Sarah to the names list, and I do shift enter. If I do this, you'll see under names, Michael, Sally, Jim, Carl, and Sarah exist now. We'll add someone else. Let's go to names and add append Jacob. And now Jacob is in the list. See that? All right. Say you didn't want to add to a list, but you wanted to add to a specific position. Say, I want to add another name to the list, but I want that name to be after in a very specific index position. So I'm going to add a new name. I'm going to add a name called Braxton, and then I want Braxton to be right after me. So I'm in the 0 position. Sally is in the 1's position. So what I'm saying is that I want Braxton to be in the 1 position. So to do that, there's a command called insert. So I would say names dot insert. I give the index. I want it to be the 1st position, and then the object is a string. Objects are just anything. Objects represent all things in Python. It's like it covers all things. And I said I want the name to be Braxton. So now when I do shift enter, you'll see now Michael, Braxton, Sally, Jim, Carl, Sarah, Jacob. So that's how you can insert into your list in a very specific position. So say I feel like later I want to get rid of Sally out of the list. You have the delete command. Well, no, it's not. It's called remove. The remove command. You can remove by item number, which is the one I'm gonna talk about. So say I want to remove Sally, I can say names dot remove, and if I type in Sally like that, and I do shift enter, Sally now is removed. So you got Michael, Braxton, Jim, Carl, Sarah, Jacob. So Sally now is not in the names list anymore. So that's something you can do. Alright, if you're trying to remove the last item of a list, the last item of a list, to remove it is the pop command. So if I say names dot pop. You can give an index, it'll remove it at a certain index, but if you don't give it an index, it's going to move it from the end. So I will show both. If I say pop and hit shift, you see it says Michael, Braxton, Jim, Carol, Sarah, and Jacob. When I hit enter, it's going to remove Jacob. So I did shift enter and Jacob is gone. But say if I wanted to remove Carl and I wanted to use the pop, but not, the pop versus the remove, I can remove based on index position. So 0, 1, 2, 3. Carl is in the third position. So I could say names, pop, 3, and then do shift enter. And now Carl is gone. So now you got Michael, Braxton, Jim, and Sarah. So that's two ways to remove. These are two ways to remove people. One, you remove it by the name. One, by the position. And sometimes removing by position is important because what if that name is in there twice and you don't want to remove all Sallys? You want to remove a specific Sally. It'd be easier to pop it, especially if you didn't put a last name or anything here. If you got just Sally and Sally, you'll need another way to get rid of it. And the pop command will do that for you. What if I wanted to clear out a list? Let's say we were done with the names list, right? And we're done with it. We can clear it. So if we hit names and type in clear and do shift enter, you'll notice now the names list up here is back to 0. There's nothing in the names list. It's just a bunch of quotes. And since we ain't got nothing in it, we might as well delete it. So to delete objects in Python, I think it works for all objects that I know, the native objects, the ones that we're covering during this tutorial series. You just use the DEL key, DEL reserve word. So if I say delete and then type in the name of the object, which is names, you will see when I press shift enter, this will delete from the workspace. So when I do shift enter, it's gone. Is adios at this point. So it's back in that RAM has been released. Remember we talked about seeing the bytes and memory locations, and it can be used for other things for your analysis. Speaking on that, you remember we talked about I'm just trying to figure out how I want to talk about this. So I guess we should talk about it. Sometimes you want copies of lists, and I need to make sure you know how to copy lists so that you can actually have two instances of it. Because by default, when you make if you say two lists are equal to each other, it's going to be pointing pretty much it's not creating a new independent list. It's assigning a new variable to the same reference location. So that's the problem with copying two lists. So for instance, say we have the ages. Let me look up here what list we have left. I like the wait. Let's do ages. We have the ages list, right? Say we wanted to make a copy and we called it, I'm not gonna be creative, I'm just gonna call it ages 2. So ages 2 is equal to ages. Okay. Shift enter. All right, in your mind, we have two lists, right? We have ages and ages 2. But let's go look at where the memory location is for these two lists. So, early on I showed y'all how to print out memory locations. So I'm gonna say print. First, I need to, I want the hex of it. So I'm gonna do hex, open brackets, and then it's ID, open brackets, and then you type in the name of the variable, ages. Then I'm gonna go 2 brackets and do a comma, and I'm gonna do the exact same thing for ages 2, so you can see the issue with this. So if I do shift, ages 2, right? Is it just 2 underscore 2? Yeah, underscore 2. So we got ages and ages underscore 2, and what you're going to notice is that down here ages is at this location, and then ages 2 is this location. And the problem with it is that they both referencing the same memory location, which means that if I change anything to the data in this location, it's going to change it for both. So for instance, to see that example, if I say ages, open bracket, in the 0th position is now equal to, I want to say it's 40 now, right? Both of them are 40. So if I want it to be 35, Say if I'm wrong, I wanted that one to be 35 and ages 2 to stay 40. If I do shift enter, you'll see both changed to 35 because both are pointing to the same exact memory location. So this would be a problem, and this is like one of the most common like copy bugs that you get, that you forget that when you copy, you got to do a real copy. I think in old languages they call it a deep copy versus a shallow copy. If I'm not mistaken, don't hold me to that. But we need a full copy, like a real copy with it being in a different memory location. And Python has a very easy way to handle it. They have a function to help you do that. So what I want to do before we do that, I want to return ages back to its original number because I said I wanted it to stay 40. So I'll just turn it back, and we're going to do the copy different this time. We're going to redo the copy. So instead of saying ages equal to ages 2 is equal to ages, we're going to say it's equal to ages dot copy. And what this does, it's going to force them to have two different memory locations. Okay, so if I do shift enter now, and it looked the same here, but what's really different is what this hexeid says, the memory location says. So if I go down here and put this here again and just run it, so it'll be in order. Now, if you look, this one is at 0 to 9 AEA, but then this one is at AEAF. This one is AEAE. So right here, this part from the F and the E are different. Now E599C0 is the location of this one, and then F0980 is the location of this one. So what this means now, those two data are actually stored at two different locations in memory, which means they're not connected to each other. One is pointing at that location, the other is pointing at that location. Therefore, changes do not affect each other. So now for ages, if I wanted to go back and change it to the 0th position to 35 like I did a few seconds ago, and do shift enter. Oh, I forgot the S. And do shift enter. You'll see now ages now is 35 and ages 2 is 40. So for most data types, and I don't think I'll cover this deeply in every video because the series is meant to be taught linearly, but what I want to say is that for all data types, you can run the hexid functions on, and most of them have a copy, like an actual copy, in which where you can copy and make sure that that copy is a unique copy to the other ones. So always be careful when you copy in data frames and planning to do something different to that new data. Just got to be careful that you copied it the right way, that you actually do a pretty deep copy of it, unless it was on purpose, that you just wanted multiple access to the same thing. Which is, there is cases that I can give you cases in which that is true. You might want different access to the data, where one example is like a weapon system in a video game. Maybe there's a mothership and it has little ships, and the little ships, when they get destroyed, it reduces the overall health of the mothership. Well, the little ship should have a reference copy of the mothership's health. So as it gets hit, it's actually changing the global health. So you don't have to have local health at each location. You do have one health that's stored in one memory location. And as those ships get damaged, the health is being reduced from that single memory location that all the ships that are in that game are all accessing. So that's an example of why you would need to do that. So it really is case to case, a case by case situation. Just want to make sure you don't think it's a bad thing. It's not a bad thing to have multiple objects or variables representing the same object. All right, I feel like I've talked that to death. Another way to combine list is by using the plus sign. So the plus sign on list actually means to add them together. So if we wanted to add the weights with the ages list, I can have let's see, both list is equal to, it's a new variable, ages plus weights. And what this does, it just creates a new list with the in that order. The ages are first because that's what I put first, and the weights are second. So now this list is a combination of both lists. You also can do the same thing, list membership. All of these data types have the membership option. We just do a couple. It works the same. So if I did, we'll call this list membership. So we can see if, like, for the both lists, it's 35 in both. If you do shift enter, yes, it is. It is in there. Well, it's 36 in both. No. So it is just checking to see, is the number 35 in this list? And yes, the number 35 is in the list. So that's a condition you can run just to see if things are in or out of the list. There's a couple of shortcuts. Now, one I want you to be careful of. One is the reverse. I think the reverse actually reverses the list. I want to look at this list. So we're going to look at the both lists. I'm not sure if it actually reverses it or just returns the reverse. So if I do the reverse command, if I do shift enter, yes, it changed it. So this list was, the 35 was at the beginning. So it's 80, 250, 136, 238, 676, 67, 12, 23, and 35. When you shoot the reverse command, just look here, keep your eyes here on the both lists. If I say shift enter, you'll notice the numbers reversed. So now it's 35, 23, 12, 67, 238, 123, 250, and 80. So that's what the reverse does. It reversed the order of the items in the list. Now, if you want to pass the reverse, there's a special way to do that. I'm just going to show it. We'll talk about it. It's a ::(-1). This will send the, and then it will send the reverse of the list without reversing it. So right now the list is 35, but when I do shift enter here, you'll see the out. That means it passed the reverse. Out means this is what it sent out. It had a return to it, so it returned this out. 80, 250, right? But if you look at the actual list, it's still in the right form: 35, 23, 12, 67, and 238. But down here, I could have saved this as a new list. So for instance, when I use this command, I must be wanting to store it for some other reason. Otherwise, I would reverse the list. So I could call this both list underscore, I don't, just give me a second, underscore 2, and then put that bracket is equal to, I'm sorry, I'm trying to create a new variable. The way I'm doing it, I hit the wrong key on my keyboard. It got me doing some weird stuff. All right, so both list 2 is going to be the reverse of this list. If I do shift enter, I've stored it. So both lists is up here, 35, 23, 12, 67. You see this reverse is at the bottom. So if you're not wanting to affect the original list, use this approach to reverse. If you don't mind affecting if you don't mind affecting the original list, you can use the reverse. Let's actually change it on the list. So that's something you should be aware of as you work on it. You can sort a list. There's a command just to sort. Let me see. So if you go down here and type both list dot sort, and you do shift enter, what it does, it sorts them from smallest to largest. You see, 12, 23, 35, 67. So that's what it would do naturally. I think the right command is ascending, is false. Sort. No, there's a command for reverse. I'm looking it up. We ain't talked about how to read that, but there's another one called reverse is true. If this is true, this will return the sort the other way. So right now it's going ascending, 12. You know what? You can have it descending. If I run this line, now it changed it to 250, 238, 123, 80, 67, 35, 23, and 12. So you can go both ways in a list. You can either go the forward way or the backwards way. All right. And so the last things, on a couple of more things to cover, we need to talk about how you loop through lists. The looping system is identical to the other ones. We'll do looping, so you can do the for value val in both list. I'm gonna print what the val say so you can see it. So when you do this way, it's going to give you each one of the numbers in order as it goes through the loop. First 250, 233, and so forth. You remember I said you have that's only 3 ways I really loop through list, really. I mean, for 90% of the time. I either do it this way, I do the enumerate way. So enumerate. And this will give me the tuple, which includes the index for each loop. So I just want y'all to get comfortable with these 3 looping patterns. So that gives me the tuple because I might want the index, and then the last I might not want it as a tuple. I want I want to store it using multiple assignments. So I might say here and actually do an index then val, and then this one I will have to print the index and the val separately to get the same information at the bottom. Because if I do the val, it will still just be the values. But here, just do a pair 0 to no. Same thing as this. Did I not run this? I don't see it. Shift enter. There we go. I must have didn't run it. So here's the tuple form because you see the parentheses. Again, we'll have a video on those on tuples actually next video. And then here is the index val form. You don't have the parentheses anymore. You pretty much have 2 variables, 2 single variables, that one has ints and the other one is storing the variable in floats, or floats and ints as it goes through the loop. So those are the 3 looping patterns that I think at the beginner level you should understand. Honestly, it's one of the most common looping patterns. And then the last thing you should understand is what they call list comprehension. I would say sometimes right out of the gate, this is not the most common thing to learn, but just to open your mind up with list comprehension, just like one-liners. It's one-liners to do what a for loop do. And honestly, I think they're faster too. I think they have a speed advantage, list comprehensions. But a list comprehension is what we call a form of Pythonic code. You'll hear that phrase is written Pythonically, or it's in Pythonic form. So a list comprehension is one of those things that's considered Pythonic, which means written in a way to be really fast, or it's written in a way that Python expects you to write it, because these are kind of written in the way of traditional coding. But it's called list comprehension. And it worked, you can almost have a whole lecture on this. But it follows a very strict format. The base form is that you open brackets, right? And then you will put the expression. I'm going to write this out first. Expression, it goes in first. Then you have the keyword for. Then the item, this is where the val part is. It's like, that's the expression of what you want the thing to do. Like, that's what you want to do with it. This represents the value. Like, so this is the expression that we're doing up here. The expression is that when you do this loop, I want you to print out. So I will put this piece of the code in the expression. The item will be the name of the thing that's doing it, that you're printing. And then the last piece to the expression is for the item. I think it's in the iterable, but we're going to call in the list. So whatever list object that you're trying to do this for. This is better understood with an example. So we've done this for loop. We're going to recreate this for loop here using list comprehension. So I'm going to open the brackets. First, the expression has to be there. So this is the expression, what's in the body. So this is what we want to do. We want to print the values. So for what item? The item that we want to print is the item that's here, the variable that's actually holding the variables. So for val, because see, I created print val for val. This is how this statement gets the val information from this statement. So it knows I should expect this val. Now you need to do it in what, like where I'm doing this in, and then you have to pick the list. So the list that we was using was the both list. So I'm gonna grab the both list, put it here, and if I do shift enter here, this is outs. It's an out though. Let's see. Oh, I get it. Print can't return. Okay. I see my mistake. Alright, welcome back. I took a little break. I saw the mistake I was making, and I want to explain the mistake. So, the reason why this is returning a none type is because this list comprehension always outs stuff. Well, the print command can't out itself. So like, it's the problem with what I'm seeing is the print command. So like, it can't give an out. So if I try to say print of I don't know, hello, if I shift enter, you'll see it says hello, but then it says none. It's saying none because the type, that's what the print statement returns. It returns a none. So I'm glad this mistake happened. So I saw it so I can talk about it. So there's nothing wrong with the code. The problem is I just can't expect it to return anything. So it's not a good example. What I want to do next, so for each value, I'm gonna do this a little simpler so you can see truly what's going on. So I just want to explain to you why this didn't work. The problem was I was using a print. This is supposed to return. This would be equivalent to returning a print and a print, and you can't do this. So I'm gonna cancel both of these out because I don't want to leave any confusion. But I will make a simpler example so it'll be easily understood. So say we had A is 1, 2, 3, 4, 5. This is A. So that's what A is. So all numbers. All right, say if we were doing it through a loop, if I wanted to show the square of each answer, if I wanted to store the square of each answer or print it out, I would say for, like always, A in A. And then I need to use the print command here because I'm trying to see it. It works here. A times A, let's just say times 2. So I just want to square it to itself. Okay, like, you know, just multiply it by itself. So if I do this and look at the screen, oh my bad, I made a mistake. It's for a value. I'm multiplying the whole list. The value, for the value in A, print the value times 2. This is kind of like what we've done at the top. So you see 2, 4, 6, 8, 10. What this is doing is printing out the square. So 1 times 2 is 2. It's multiplying it by 2. I mean, 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. And 5 times 2 is 10. All right. So to do the exact same thing with list comprehension, I can't use the print command, but I can store the results. So say if I had a new variable called B. All right, B is equal to, and we're going to do what we did earlier. The expression I want to do is the val times 2. That's the expression. So I would say val times 2. All right, and then you'll say for, that's what this part is, the items of it. And then so the items is represented as the val. That's this part. Val goes in the second position because that's the thing that you're doing this expression on. So val, and then in the list that we're referencing is A. So what this says, for the list A, we create a variable that we want to square for each value in A. That's what this means. So for each value in A, we have this variable that represents each value and we want it squared. So when I do shift enter here, you'll see B has 2, 4, 6, 8, 10. B has exactly what A would have had it here if I had printed this out. And the reason why people like list comprehension is that right now I did this in one line of code. I was able to get B equal to this and get the resultants onto the screen. Say I didn't do it this way. Say if I didn't want to get B this way. Say if B was empty. So I'm going to empty B. B is equal to this. So it's empty again. Alright, to do this exact same thing, I would need this variable to be empty. And for each loop inside here, so we printed it out, right? I have to write another loop. We talked about the append up here, right? How you add to the end of a list. So the list is empty now. I will have to say b dot append val squared. So now for every loop, it's going to add the results in this loop into the B list. So if you look at B here is empty, if I run this line of code, B now is 2, 4, 6, 8, 10. So it required me to create a new variable and then add values to it to create the list. Where if I make, but the other way, if I make this 0 again, without having to do none of this, I can mark this out and I actually can get rid of this entire list. And I'm just doing shift $. So with none of that existing, I can do it in one line to do the exact same thing and do shift enter and get the same numbers back. And that's the power of list composition. It allows you to list composition. It allows you not to have to do all these extra steps just to get some type of statement to run or some type of expression to move forward. You can do it all in one statement and do everything that you need for that object. So again, I think this honestly is the only video I need to make for this because it covers most of the things you need to know at a beginner. But we'll do a little recap. The recap is that first we talked about creating an empty list, which you did that. We added items to the list and talked about how to get access to the different items using zero indexing. We combined the list to show that you can have multiple types of different data inside the list. We also talked about how you can index it and slice the list, and then we discussed the concept of a list of lists, or so how you access data when the data is multiple lists. First you had to get to that list position, and then next you add the list index to get to that actual item. We talked about different list manipulations, how to add to the list, how to insert into specific positions, how to remove items out of a list, how to pop things from the back of a list, or how to pop things from an index position. We talked about how to clear a list, and then also how to delete lists. We talked about the right way to copy lists, so that you don't have a variable, so they won't be actually referencing the same list unless that's something you actually want. We talked about how to see the memory locations of objects, which is something I do quite often. Membership of a list, see if an object is within that list. Reversing lists, sorting lists, looping through lists, and lastly talking about list comprehension. This is a lot. The list is, like I said, get comfortable with doing all these items in a list. Just how to move around, manipulate and stuff, because the better you're able to do that, the easier it'll be to move to the next steps in your data analysis journey, when you start trying to actually do data manipulation based on a list. So thank you for watching this tutorial. I hope it was beneficial to you. The next tutorial will be about tuples. We'll talk about that in the next video. I wish you the best, and you take care and have fun programming.